to write down the constructors, how constructor overloading works, the types of different types of constructors, no argument constructor or default constructor we see, and parameterized constructor. Then constructor overloading. Then we have seen the use of this keyword. Okay? Now today we are going to see the next topic, that is first we are going to see the difference between constructor and method. Okay. So basic differences, as we have seen that constructor is basically a special type of method itself. But there are few differences between constructor and method. What are the differences? Constructor is used to initialize the state of an object. Okay. So it is always used to initialize the object itself. And method is used to expose behavior of an object. Okay. We write down a method for defining any behavior of that object. Then constructor must have not return type. We have seen that constructor never have a return type. We never give any return type to it, but it is by default returns object. Method always have a return type. If you don't want to give any return type, then we use void as a return type. Okay. Constructor is invoked implicitly. It is implicitly invoked if you are not writing any constructor in your class, and it gets, whenever you are creating a new object, it gets invoked implicitly. Okay? When the statement is executed. But method is not invoked implicitly. You have to invoke it explicitly. You have to call a method explicitly. It is not directly gets called implicitly. Then the Java default constructor, if you don't have any constructor, then the Java compiler creates a default constructor and use that constructor. But if you are not providing any method, Java will not create any method. Compiler will never create any method. If you want a method should be there, you need to create it on your own, right? Constructor name must be same as the class name, and method name may not be same as the class name. You can give any other name also to the method. One second. Okay, the next topic is anonymous block, or we say it as an instance initializer block. We can write the constructor, we can initialize the members of the class or object in a constructor as well. But there is one block that is known as instance initializer block. Here the mechanism is same. If you want to provide the instance initializer block, you can do that anywhere in a program, anywhere in the class. You just have to mention the brackets, opening and closing brackets, whatever statements you want to do, you can write it here. Those statements by default gets copied in the beginning of a constructor. All the constructor, whatever constructors you have in a class, all the constructors after super keyword. Okay. So these statements gets copied in the constructor itself, and that gets executed when the constructor gets called. Okay. Automatically. You don't have to do anything. It is also used to initialize the instance variables. We will see one example of instance initializer block, or we say it as anonymous block also, because the block will never have any name. That's why we say it as anonymous block. We'll create one class. anonymous block example. Include the main method. So we'll create one class here. Suppose the class is, we will create one class named, suppose circle. In this circle class, I'm going to give one member, that is radius, integer radius. That this is the member. Okay, so we will generate the default constructor for this circle class and the parameterized constructor also. So we will generate it using the source constructor using fields. First is the parameterized constructor, and second one is using super class. That is a default constructor. I am removing this super. We don't require that right now. So here we will give some value to this default value to the radius. That is suppose 10. Okay. And here in the parameterized constructor, whatever the value you are getting as a parameter, that will set to this radius field. Okay. Here we will write down one statement just to understand. This is a default constructor of circle class. And I will write down the same statement here. I will change only parameterized constructor. Parameterized constructor of a circle class. Okay. Now we need one more member here. Okay. But that is, we are going to calculate the area of this circle. So what is the, you can say, for area of a circle, we need to give some value also. But what we will do, we will just display the values here also. For the radius, we have set the value to the radius. Radius variable, radius in default constructor. Because we want to use the anonymous block, that's why I am writing this statement. Radius in parameterized constructor. Okay. Now, to perform, we will add the anonymous block or instance initializer block just with the brackets. You can write that anywhere. This is known as anonymous block or instance initializer block. Now, if I am changing the value of this radius to 20, then it will get changed everywhere whenever you are performing, or this statement gets copied basically after the super keyword itself. That means before executing all these statements. Okay, super keyword is always the first statement of the constructor. We are going to learn the super keyword in inheritance chapter. So that will be the first statement in the constructor always. So after the super keyword, these all statements, whatever the statements we have written here in this block, this is an anonymous block. We are not giving any name to this block. That's why it is known as anonymous block. Okay, I will write down the statement. System.out.println. This is okay, the same anonymous block or instance initializer block. You can write n number of anonymous blocks in your code. This is block 1, suppose. I can write n number of anonymous blocks. This is second block, suppose. Initializer block 2. Okay, this is block 2. Then, but that should be outside of a constructor or a method. Okay, if you are writing any method, then that is considered as a method itself. This statement should be outside of your constructor method, but anywhere in the class. Only you are grouping those statements using this brackets, or you can say braces. then that is known as the instance initializer or anonymous block. So if we want to calculate the area of this circle, we will write down one method here. That is a method, instance method itself, public double area. Okay, so we will directly call the area written. You know that the circle area formula, right? That is pi into pi r square basically. So instead of pi, we will use value 3.14 into radius into radius. Okay, we are returning this value. Okay, so now we will create one object of this class. Circle C is equals to new circle. Here I am going to first use the default constructor. Okay, then now everything we will call the area method as it is returning double value. So we will display the area of circle is equals to using plus C dot area method. Yes, so you can create the variables in anonymous block also. I will create one, which are A is equals to 60. Okay, so you can create that. I will display this A variable value here. But whenever you are creating any variable inside an anonymous block, the scope of this A variable will be till this block ends. Okay, you cannot access this A variable outside of this block. Okay. So similarly, we have changed the value of radius here. So we will display that also. System.out.println value of radius in anonymous block is equals to radius fill value. We are changing it, right? So whenever you are calling this area method, it will take the changed value itself because these statements gets copied before this. Okay, so first the radius value will be 20, and here we are using this dot radius equal to 10. Then we will see which value it will take, and it will use that value here for calculation of area directly while executing this. Similarly, we will use another value parameterized constructor and call the area method using the second object C1 object. Okay, I'm executing this. We will see one by one what will be the output. So to just understand the output, we will add some lines after every block so that you will understand the output here. After the constructor, at the end of the constructor, at the end of the anonymous block. Okay, now I am executing this program, the Java application. Let's understand the output. So first anonymous block instance initializer 1 is called. Here we have given the value of radius is 20, right? After that anonymous block instance initializer block 2 gets called. The value of A variable we have created there, that is a local variable, value is 60. Then the default constructor gets called, and we have set the value of the radius in the default constructor is 10. Now using this 10 value, the area gets called. Okay, area method is using this 10 value, which is a recent value. We have changed in the first anonymous block. But as I said, these statements, whenever all the anonymous block statements gets copied before these statements of your constructor. That's why when we are changing the value, again we are using this dot radius equal to 10 that gets executed later. That is why the current radius value is 10, and the area method is using the recent value, that is 10. Okay, then the next, for the another block, all the anonymous blocks are again executed, same value is 20, anonymous block instance initializer block 2 executed, value is 60. Okay, parameterized constructor gets called, and we have passed the value 30 to the parameter. So the area method is using recent value, that is 30, for calculation of area. Okay, so basically these are blocks. If you miss something, or if you want to add anything that gets repetitive execution, those statements you can add into the anonymous block. Always what n number of anonymous block you can add in your class, and those all anonymous block statements are always gets copied into all the constructor calls after the super keyword, but before the statements of the constructor. Okay, clear? Understood? Go through this example once. If you have any doubt, let me know. You can ask. Otherwise, we will go forward with the next topic. Any doubt, anyone? So you can initialize the values to the fields in instance initializer or anonymous block also, and in the constructor also. Whatever you need to use, you can use it. Okay. Only difference is the statements of the anonymous block gets copied in the starting of every constructor, that gets executed for every constructor call, as you can see here, for the default constructor also and for parameterized constructor also, both anonymous blocks gets executed. That is the main thing. So basically it calls the anonymous block multiple times, it executes it multiple times. So only if necessary, you can use these anonymous block or instance initializer block.
Ma'am, just one query. Like I have got a radius variable here. So this is getting changed every time in the anonymous block. So whatever the last value of the radius is there, that is going to get taken care, right?
Yes.
Okay. So where if I'm using some equations or any of the calculation transaction, so whatever the previous value of radius is there in any of the anonymous block, that is going to get considered.
No, whatever the recent statement will be, if you are
Recent
changing the value, that is gets considered.
Recent statement. Okay.
Okay, because they basically anonymous block is nothing but you are copying all these things here. Okay, so first
Okay.
these statements gets executed,
Oh,
and then your
okay.
statement, these statements gets executed. But what we are doing, we are changing this part. I am removing these statements from here, and I'm writing it inside the anonymous block. Okay, so here we are changing the radius value to 20. But
Okay.
the recent statement is this radius we have changed again in the default constructor to 10. If you are not giving this value, then whatever the value instance variable value you are setting here, that gets considered. So whatever recent value you are setting,
Okay.
that
Okay.
gets considered.
So any number of anonymous blocks, I can just go on creating it.
Yes, you can write
But
down
but
it.
what is the main purpose? Like I have understood about the constructor, private, public, protected. So many constructors are there. Understood. But this anonymous block, what is the real usage of this?
So it is also used for giving the values to the instance variables itself. Okay. So
Okay.
you can use instance variable if you don't want to write down any constructor. Then you can use this instance initializer block. Only thing
Okay.
is here that whenever you are writing any anonymous block, all the statements, all the instance initializer block statements gets copied at the starting of your constructors. Okay. So if a class doesn't have any constructor, and you want to
Okay.
suppose this class, I don't want to write down this default constructor, but I want to give some value, default value to this radius variable or this
Okay.
radius field
Okay.
state. So you can
Okay.
do that, you writing the anonymous block itself. There is no need of creating a constructor. So default constructor, you are not
Okay.
writing, no problem. The value gets default value, you can set using anonymous block.
Okay. So suppose I'm having one constructor like public circle and I'm having 10 different blocks, anonymous block. Okay. So these all 10 anonymous block statements will come and execute in the first position of your constructor.
Yes.
Okay.
Always all the anonymous blocks
So suppose if I have got 10 anonymous block, every time I'm changing radius value 10, 20, 30, 40. So like that. So suppose I have got around 10, so it will be around 100 radius. So all that code will be there within your constructor.
Yes. It actually gets copied while calling a constructor itself by the compiler.
Okay. So as we don't have any function name, the execution is done through the constructor.
Yes. But we
Okay,
cannot
okay, okay.
perform or you cannot call that.
Okay, okay, okay.
That's why
Understood.
it is considered as the part of a constructor itself.
Okay, okay. Thank you. Understood.
So suppose I am not writing this default constructor, but we have written this parameterized constructor. Then we have to call the parameterized constructor itself, but the anonymous block statements gets copied while calling a parameterized constructor before these statements. Okay. All whatever n number of anonymous block you are writing, all the statement gets copied after the super keyword. Every constructor has a super keyword. Okay, first statement should be the super keyword. After the super keyword, these statements gets copied, actually gets copied by the compiler while executing line by line code. Okay, while interpreting basically, and then it will append the statements which you have written in a constructor. Clear? So it is also the instance initializer block. You can use it for initializing instance variables. Okay, and the main thing that I said, it will execute for every constructor call. It will execute at least once. Okay, all the anonymous block statements gets executed in every constructor call.
Okay. So suppose if I'm having one default constructor, so below that I'm going to have number of anonymous blocks. Then how the way you have created public circle int radius. Again below this few more anonymous blocks. So related to one parameter, these anonymous blocks will be binded. No, like first one is default constructor, right? So you have written one of the anonymous block. So this, yeah, whatever you have selected, so that is again a part of your default constructor.
This is a part of the default constructor which I have written into the default.
Correct. Then you have created circle with one parameter, right? Below that, one more anonymous block is there. Circle with int radius.
Yes.
So this is getting called for parameterized.
No. Yeah,
okay.
all the anonymous blocks gets called for all the constructors. If you are writing 3, 4 constructors, for all the constructors, all the initializer block gets called, and these will get called in a sequence in which we have written it. Okay. So first this anonymous block gets called, then this anonymous block gets called. If I have one more, then that will get called, and then the statements of a constructor gets called. You can see the output so that you will be able to understand. So for first default constructor part, where we have created one object using the default constructor and we have called the area method. So while calling a default constructor, the first anonymous block is called, where we have given the value to the radius, which is 20. Then the second anonymous block is called, because as per the sequential execution, second anonymous block is we have written after the parameterized constructor, and where we have defined a variable also. Okay. And then the default constructor statements where we have set the radius value to 10 and the default constructor statement that gets called. Okay, so this is all for a default constructor call itself. So you can see here all the block statements. There are two anonymous blocks. Both are called before the default constructor statements. Okay. Then the method gets called, area method, which I have called using here in the system.out.println statement. Then again, we have created one object using parameterized constructor. So for parameterized constructor call, again, these two blocks gets executed with the same statements because we have not changed anything here. Okay. And then the parameterized constructor statements gets called and we have set the value of radius to 30. That is considered current value or recent value. And when we are calling the area method, this 30 value is used for calculation. Okay, so this is for second object, parameterized constructor. All the anonymous block gets called in the sequential manner in which you are writing the anonymous blocks. And for this default constructor also, both anonymous block gets called in the same sequential manner as you have written. Clear? So if you are writing one more constructor, then these two anonymous block will get called for that third constructor as well.
Okay, so suppose if I don't write any constructor at all and I'm writing only the blocks, that is anonymous blocks, 1, 2, 3, 4, 5. So in the sequential way, one after the other, all the things are executed.
Yes, but if you are not writing any constructor, okay,
correct.
Then all these statements get copied.
So these blocks are, these blocks are common for all the constructor, whether it is default, parameterized.
Yes, for all the
parameters. Okay.
And all executes before constructor statements execution.
Correct.
Okay. But after the super keyword, remember that after the super keyword. Okay. Clear? Any more doubts, anyone? Shall we go ahead? Okay. These anonymous blocks are known as non-static also. Okay. What is static? That we are going to see in the next point. So the next point is next point is static keyword. Static keyword. So Java static keyword is mainly used for memory management. Static is non-access modifier. We have seen that non-access modifiers slide also. And this static keyword we can apply to variables, also known as class variables, to a method, also known as class method, to a block, and to a nested class. Okay, so static are 4 different static parts are there: variable, method, block, and nested class. Okay, so static keyword is used for mainly memory management. You know that we have seen the JVM architecture, right? In that we have seen basically the class loading statement, right? So I will open that. Okay, this is nothing but your JVM architecture, right? So here we have seen the loading of a class file, right? So at the time of class loading itself, that means while loading the bootstrap class loader, extension class loader, application class loader, this in the loading time itself, all the static members gets the memory allocations. Okay, we have seen where the memory for this static members gets allocated, or all the final phase of class loading, all the static variables will be assigned with the original values and the static block will be executed. So everything done at the time of class loading itself. Okay, all the static members are executed at the time of class loading itself. Okay, so there is a name area, which area? The method area, where we can store the static variables values. Okay, then the method, static method, memory allocation, all these things will be done at the time of class loading in the method area. Okay, so because why the static members are shared among all the resources, all the members, is because method area share, it is a shared resource. It is only one per JVM. That is why when we are using the method area for storing the static variables value, all the static variables data will be shared and it gets loaded at the time of class loading. The memory allocated for the static members is always at the time of class loading. Okay. Now, all the static members will be allocated a memory at the time of class loading. Okay. And it is mainly used for memory management. We have seen the memory management, right? So this first we are going to see the static variable, which is commonly used for instances where we can create a static variable and all instances can share a single copy. When to use a static variable? If you want to use, or the value which you want to use it as a constant, okay, which should be never changed as per the instance values, okay, or instance variable values. For this example, I can say that this 3.14, that is a pi variable value, right? So pi value, this is fixed value. For if I am creating any variable here or the field here, that is double pi, and I am giving value 3.14 here, then this value, this variable becomes what type of variable? It is an instance variable. You can change the value of pi anytime, right? Because it is an instance variable. And if you are using the instance variable, all the objects will have its own copy. For this circle C1, objects will have own copy of the pi variable, and you can change it also. But I don't want to change the value of the pi because that value should be fixed. This should be constant. We never change the value. It is fixed already, right? It is never going to change. And as per the instances, it should never change. And we must not waste our memory by using this variable as an instance variable, because unnecessarily for different objects, we are creating that variable and giving the memory for that pi variable. Correct? क्योंकि हर बार पाई वेरिएबल की वैल्यू तो चेंज होने नहीं वाली है, वो तो फिक्स ही रहेगी. बट इफ यू आर क्रिएटिंग मल्टीपल ऑब्जेक्ट्स, तो वो पाई वेरिएबल की वैल्यू तो हमेशा वही रहेगी, बट अननेसेसरी आप उसके मल्टीपल कॉपीज बना रहे हो डिफरेंट ऑब्जेक्ट्स के लिए, तो एट दैट टाइम you should restrict the memory management. You should do the memory management. You should declare these variables in a such a way that it should get the memory only once, right? That is why in this scenario, you can select, you can use the variable should be static. Okay, so so that all instances can share a single copy of that variable. If any instance changes the value of static variable, it will get affected for other instances also. So it is not that it is basically a constant. You can change that value, but that change will get affected for all the objects. Okay. The static variables get first loaded into memory at the time of class loading. This is the most important. All the static variables gets loaded into the memory at the time of class loading. So we will see one example. That is, for example, you all are taken admission into the Stu Valley, right? For all the admission details, if I'm asking you college name or any institute name, everyone is going to give the same name. No one is going to give some different names. You have taken admission in one institute itself, right? So you are going to give the same name. So instead of creating that variable as an instance variable and wasting our memory, we can select the static as a non-access modifier for that particular variable, so that the memory will be allocated only once and this name will be shared among all the instances of that class. So these are known as class variables. Okay, these are known as class variables. These declared with static keyword inside a class. You have to declare those variables inside a class. The static variables are loaded statically in the static context along with the class at the time of class loading. Thus, here is the static memory allocation. So we have already seen this part in the JVM allocation. Okay, JVM architecture, I have explained that right now also, but in detail, we have seen that into JVM architecture. These have only one-time memory allocation. This gets allocated only once. All the static variables are accessed using class name. These are class level variables. That is why these are bounded to a class and we can access these variables. We don't require any instances of the class. You can directly access these variables using class name. No need to use object of that class. Okay, so we will perform one program to get the clear idea. So I have already explained this scenario of the pi variable, right? So we will perform that. We'll create another package in the module 8 itself for static keyword. Because there are three different parts: variable, method, and block. So that all this should be saved at one place. I am creating the separate package. Name of the class. First, we are going to see static variable example. I am including the main method as well. So here we will create one class named demo. Okay. In this class, I am creating one variable I. This is an instance variable. Instance variable. Okay. So the value or the memory gets allocated for the instance variable when we will create an object of this class, and these will have the separate memory allocations for separate objects, right? Now here we will create static variable, static int, suppose j, and I'm specifying value to it as 10. Okay. So you can declare the static variable in this way. You have to use static as a non-access modifier. Data type, you can add access modifiers also, public, public. Static variables are never private. Okay. We never use private for those. Okay. Static variables, you can use public, protected also. Okay. You can write here, you can try that. If I am creating private, you can create it private also, but we never use the private for static variables. Very rare case. You can make it public. Okay. If you are not specifying any access modifier, that means it is default package level, right? Or you can use it as protected. Okay. So all access modifiers you can apply to the static variables also, same as the instance variables. Okay. If you are creating the member as static, the name of this variable in this way, then you can see this is in the italic form. Okay. Just to identify that this is a static member, it is always in the italics form. And I am assigning some value to this as a 10 value. Okay. This is known as static variable or class level variable. Or level name, class variables you can say. Okay. These are known as static variables or class variables. These are instance variables. So all the instances of demo class share this single copy of this static integer j variable. Okay, for this single time memory will be allocated. When the memory gets allocated? At the time of class loading. Okay, so in this example, we will simply create one default constructor. In this default constructor, now in the constructor, you can set the value to both instance variable as well as static variable also. Okay, but here I am setting the value to this dot I 20. You can set the value to j variable also. It is not compulsory. It is never said that you cannot give the value, but it initializes only once. Okay, that means the memory gets allocated only once. You can change the value any point of time. If you are not giving any value here, no problem. You can initialize it in the constructor as well, or later also anywhere in your program. But the memory for this is allocated at the class loading time itself. Okay, so here I am specifying value. Now I will generate a toString method, or you can create a separate method, display method. I am creating a toString method to add the values. Now here you can see only fields, that is I is added, but I want J also. Okay, we will add that manually. Okay, I want the value of J also. J is equals to, I'm adding J variable value. Okay. So in the toString method, you can see the value of I and J both. So this is a default constructor. I am setting the instance variable value, as well as we can set the static variable value as well. Now, to access this variable, we will create first, I will write down system.out.println value of J before is equals to, we will directly access the static members. We don't need any object of this class. You can access it using class name, because these are bounded to the class, and that's why you can access these using class name. So we are using the class name dot operator and then the name of the static variable. All the static members you can access in this way. Okay, now before update, I will change the value of this demo.j, okay, to 92, and we will display this again. Okay, J after update. So it will get updated. Now we will create one object also. Demo D is equals to new demo. Okay? Demo D equal to new demo. Now we will display the values system.out.println. Directly this D object I am displaying because we have added the toString method. Okay? Similarly, we will create one more object, new demo. Here I am changing the value of I, which is an instance variable, so that we have to access that using instance object. Okay, instance or object. You can use object only to access the instance variables. You can access the in static variables also using this, but that is not required basically. We always use name of the class, but it is never wrong that you can access those values also. Okay. So here I am displaying system.out.println D1 before update. Okay. Before update, I'm changing the values. Okay, I'm not changing the value of J. D1 after update. Okay. Now you will see here J variable value which we have assigned, that will be same for this D object and D1 object. Okay, because both objects, both instances share a single copy of this static variable. I will execute this to understand this clearly. So value of J before update is 0. Okay, because we have not initialized the value here. We have initialized the value of static variable into constructor. Okay, that is why default value as per the integer data type is 0. So that is why we are getting here value of J before update, which is 0. We have changed the value, we have initialized the value to 92 in this way. Okay, then after this, we have created one object, demo constructor we have called. In this demo constructor, we have set the value to 20 and J value to 60. So we are getting the same output, right? Then for D1 object, again the value is 20 and 60 before update. We have changed the value of I variable, which is 30, and J variable value is same for 60. So you can see this is the first object and this is the second object. We are, the value is same 60. It is not changed. Okay, because these are having the same shared resource. The memory for the J variable is allocated only once. The value gets changed only once. Okay, so memory is allocated when at the time of class loading. Clear? These are few points. Understood? Any doubt? Static variable, static keyword. In that static keyword, we are learning first point, that is static variable. So whenever you want to create a variable which should be shared among all the instances, or the value which should not get repeated, which has a single value, that time you can select that variable as static. You can declare that variable as static. Clear? Understood?
So that means only a single memory block will be there for that particular variable. Is it like that? Static means?
Not single memory, you can say. Only one time memory allocation will be there.
Okay. If we are changing that particular value, again, we are referencing to the same memory block.
Yes, I will show you in a pictorial representation.
Okay.
So suppose this is these are two objects. Okay, so this is a demo D object. Okay, and this is demo D1 object. Okay. So as we have seen, instance variables have their own copy as in the objects, right? So I variable has, so this demo D has this I variable, which is I have written here, and the value is separately stored here, that is 20. For this demo D1 object, I variable will be there and separate value will be there, suppose 30. Okay. So I am considering that the demo D1, demo D, these are two different objects. They have the instance variables, and those instance variables values are stored according to the memory allocated for those instances, right? So I will write again, I will be 20 value, okay, and here I am giving I as a 30 value. Okay, similar way, suppose I have one more object, that is D2. This is demo D2 object. Okay, this will also have the instance variables, I variable, which is a separate variable, and suppose it has the value 60. Correct? But as we have seen, instance variables have their own memory allocation, but those memory allocated for the instances, and they will have its own copy. But whenever you are using static variable, all these will share a single memory allocation for static members, and only single variable memory gets allocated. For example, here we are using static J variable and we are sharing this value 92 in all objects. Okay, so memory is allocated only once and all these will share this single memory allocated. Clear? They will not have a separate memory allocation for each and every instances. They will be sharing a memory allocated for the static member. When the memory gets allocated at the time of class loading. Okay? Its actual values are set at the time of initialization. Initialization process in the class loading itself. Okay? Where the variables stored in the method area. Okay, all these things I have already explained you, and that is why these are bounded to the class. You can access those using the class variable class name itself. You don't have to create the instances, and the memory is already allocated, so you can directly access that using class name. Memory is already allocated, values are already stored. So because the instance variables will be will the memory gets allocated when the memory gets allocated when you are creating the object of that class, unless and until they are only what we can say they are only blueprint, right? Those are only blueprint, or we can say it as only templates. Unless and until you are creating any object of that class, the memory will not get allocated, and each and every object will have its own copy of instance variables, right? But for the static members, they share a single memory allocated when the memory gets allocated at the time of class loading. They are basically static members are always shared resource. Okay, so when you want the data, which it should be same for all the instances, and you don't have to give or allocate the memory again and again for the same data. To save the memory, you can declare that member as a static member. Clear? Yes, Shruti.
So this 92 value, we can keep on changing it?
You can change anytime.
If
As
I'm
we
access
already changed
Okay.
here multiple times, you can see we have initialized in
Correct.
default
Yes.
constructor to 60. We have changed the value to 92. We can keep on changing.
Yes.
Only the thing here is we are saving our memory, because for instance variables, we are getting the separate memory allocations. So for if you are making this J variable as a instance variable, so J will be a memory will be allocated for D differently, for D1 differently, and for D2 differently. But all these will have suppose same value. I want to save only 92 value everywhere. For the J variable will have the same value for all the instances. So why to waste a memory, right? Why to waste a memory? You
Okay.
can
Yeah.
assign that only once rather than giving the separate memory allocation for every instances. You can assign the variable only once and you can allocate the memory only once if they have the same value, right? So we can perform that using static keyword. Okay, that time you can select that variable as or you can define that variable as a static. Okay, understood? Same example we have seen here.
Yes.
It's
Yes.
pi. So pi value is never going to change. It will be same for all the instances, right? So why we create that variable as a, if I am creating pi variable here with the 3.14 value for D object, for D1 object also the pi variable value will be same, 3.14. And for D2 object also pi variable value will be same. We are not changing it, right? So same value are there, but three different memory allocations for three different objects. It is a vestige of memory. So instead of that, you can define this pi variable as static, okay? So that static integer pi, and you can assign the value to 3.14. So the memory will be allocated only once and the value will be basically shared among all the instances, right? So there is no need of creating it again and again, allocating a memory again and again. I have only taken the 3 objects example. If there are hundreds of objects in your program, then for hundreds of objects, this memory will be wastage because the value is same. At that time, you can select that variable as a static and you can define it as static. Okay? When to define it, understood?
Yes.
So
If you want to use the memory, single memory block, that time we can use this.
So basically we say in a simpler way, when you want the value should be, when the value will be same for all the instances, then you can create that as a shared resource by using the static keyword. The value you are expecting will be same for all the instances of the class, then you can select that variable as a static keyword. Or you can define that variable as a static variable. Okay.
So working is just like constant, I think. Constant. How the way we are taking constant.
Yes, but it is not constant. You can change the values also, right? But if you are changing a value, then it will change for all the instances.
Correct.
Okay. That is, memory is allocated once. It is a shared resource. It is shared among all the instances. That is why if you are making a change to that variable, then the value will be changed for all the instances. It is same, it is, we cannot say that it is a constant, but it is somewhat like a constant. Okay, we will see how to define a constant which will never change. Clear? Understood the concept static variable?
Yes, yes, yes.
Right? Okay. So any doubt, anyone? Okay, so in the next session, we will end our session for today here. If you have any doubt, you can always ask. And we will see the static method in the next session. What is the use of static method? Why main is declared as static and how to define the static methods. Okay. In the next session. Thank you, everyone. You may leave.
Thank you.
Thank you. Sir, ma'am, you can end the session.
Okay, ma'am. Thank you so much.